to see you here for this presentation on the design of PAYG Retirement Systems toward more generational and intergenerational equality. At least for the case of Algeria, this formula, or the conventional formula to estimate retirement benefits, is calculated in arbitrary way, which aims to calculate the first retirement benefits as a product of the number of years of contribution by 2.5% by the final wage. In our point of view, that might lead to huge inequalities when comparing people or different people from the same within the same system. So our objective here will be, in first, to visualize these inequalities, and then to propose a model to adjust the retirement formula to ensure more equality. And for as an application case, we consider the Algerian male retirees covered by CNR. Here, retirement or contribution retirement career is taken from the investment return point of view. And equality means that the different scenario might lead to approximate IRR or internal return rate. Scenarios that we are considering here are set according to mainly three variables. We have in first the age of starting work to be from 18 to 55, the year of retirement to go from 2015 to 2030. The number of years of contribution are set to be from 15 years to 40 years. Assume that all workers contribute for retirement. That means that there is an automatical contribution when we start working. And then that the working career is continuous and it's concentrated to the end of the working career. And we assume equally that wages are equal for all individuals aged X during the year T. So that means that we are not considering inequality in wages. Here, in one side, we have the expected or the present value of the expected contributions. That's the contribution, which equal to the product of the wage at the age X and time K multiplied by the cotization of the rate of contribution at time T, for which we associate the probability to survive to payment to the different payments date, and here the discount ratio. On the other side, we have the retirement benefits associated with probability to survive from the age of retirement to the different age of payment, under the conditioned by the probability to survive from the age of starting work to the age of retirement. And here's the result showing the IRR according to two variables: the age of getting into the contribution system from one side, and the age of retirement by another side. Each square represents the average corresponding to each age of retirement and each age of getting into the system. And we observe the huge inequalities in terms of IRR, which goes from a minimum of 9.8% to a maximum of nearly 14.5%. This difference of around 5% can lead to huge inequalities regarding the wealth accumulation along the working retirement career. And here's the density plot. We observe that a great part of the scenarios are concentrated in between 12% and 30%. Our objective here is to reduce the dispersion of this density or the density plot. The solution that we propose is to adjust the previous retirement formula that we have already shown. The formula reflects the case of fully funded system We don't aim to move to fully funded system. We just need to use this formula to deduce a new formulation of the retirement formula. If we try to write this part of the equation in function of W star is the final wage, and the other part of the equation in terms of the first retirement benefits. That allows us to write the first retirement benefits, it's equal to A on B multiplied by the final wage. Here is the evolution of the ratio A on B according to the number of years of contribution. Our idea at this point is to use a linear model, a log model, to simplify this distribution. And we compare three models: a linear model, a log model, and the log-log linear model. As a result, the linear model gave better fitting quality, and it leads to this new formula. What if we want to improve again the quality of the model? For sure, we need to include more variables. And here we propose two types of models, GLM models and log GLM models, based on two variables, which are the year of contributions and the age of retirement, and three variables GLM based on the years of contribution, the age of retirement, and the year of retirement. And here's the fitting result. The best models are the two models on the top, leading to thus formulas, thus new formulas. So we note this model to be model 2 and this one to be model 3, while the first proposed model is model 1, and the initial formulation is said to be model 0. And here we observe that there is not a big difference when we compare model 1 with the model 0, but we observe an improvement. The surface is getting blue. Blue means that all the individuals have an IRR situated in this range. And that's the result obtained with the last proposed models. If we compare the density plots, that's our original model, actually or currently in use in Algeria. The first model doesn't provide significant effect, but the model 2 and 3 allow concentrating the IRR. The objective now is to eliminate the extreme values in order to keep all the scenarios in between 11% and 13%. And we need to impose some new criteria to access to retirement. And that's the final surface and the final distribution of IRR or of scenarios by IRR after having eliminated the extreme values. And the blue here is more evident than the blue in the first plots. So as a recommendation, we recommend to set the minimum years of contribution to be 25%. And in the second, we observe a huge inequality because of the revision of the contribution rate for retirement from 5 to 11% in 1991. This revision resulted to huge inequalities between the people who start contributing before 1991 and those who started contributing after. So as a conclusion, so we have shown in this paper that the classical PAYG retirement system, especially the one used in Algeria, lead to important inequalities. And we have proposed a formula allowing to reduce these inequalities. But some regulation is needed to eliminate the extreme scenarios. And we plan to extend this model to male-female populations and to consider also steady wage evolution or low inflation case, and also to consider the case with wage inequality. Thanks.